Okay, so question number 9. Okay, so we're asked how to find a scale factor. So let me just change the screen on this side. Okay, so question number 9. Excuse me. So let's go through what the junior tutor went through for a scale factor and how to define and describe it. So let me do a quick skim over this. So they're giving kind of, have you ever wondered how machinists, etc. Before we begin this lesson, you will want to recall 2 math terms, similar figures and ratios. So here they give you kind of 2 figures and they're trying to explain how the scale factor works through these figures. So here a ratio is a fraction that compares 2 quantities. This picture shows 2 similar 4-sided figures. Essentially they have kind of each side labeled over here and they have like an enlarged figure of this and it's scaled to this enlargement. You can see that this side is 3.2, this side is 1.6, so 1.6 times 2 will give us 3.2. Similarly, 4.6, so this is a little small. It might be a little tiny on your screen, but here it says 4.6. Here it says 2.3. So 2.3 times 2 is 4.6. And it's similar for the rest of the sides. So they just multiplied 2 by every side and drew this over here. So going on, in 2 similar geometric figures, the ratio of their corresponding sides is called the scale factor. So this is kind of the definition of the scale factor. To find the scale factor, locate 2 corresponding sides. So we can locate this side and this side. And in this example, the scale factor from the blue figure to the red is 1.6 to 3.2, which is a 1 to 2 ratio, which makes sense. This means that for 1 unit of length on the blue figure, there are 2 units of length on the red figure. And that's true. Okay, going on to this example down here. So similarly, they have the same idea, kind of, they have a bar graph. You have 2 on this side, and it's doubled to 4. You can see on this line. And then 1, 2, 3, 4 on this side, and 1, 2. So same idea, 1 to 2 ratio. Excuse me. Okay, let's scroll down over here. So they also give a cube kind of explanation, but really let's go down to so I'll give you kind of the simple explanation. This is kind of a long explanation, but essentially it's this definition that we highlighted over here. So this, in 2 similar geometric figures, the ratio of their corresponding side is called the scale factor. So if we had a square with a side of 2, 2, 2, 2, and we had another square that was a little bigger at 4, 4, 4, 4, we know that it's a 2 to 4 ratio, which is equal to a 1 to 2 ratio. Which makes sense, and that's kind of your scale factor, the ratio of their corresponding sides. So it could be any shape per se. So down here you can see that, I believe, yeah, so this example is a good example. So this is a trapezoid shape. You can see that it's flipped on this side, but we can see that if we look at this side, the angled side, we have 1.41, and then this side is 2.82. So 1.41 times 2 will give us 2.82, so we know this is a 1 to 2 ratio. Similarly for the base and the other sides. The only thing that in this situation this is flipped, but it doesn't matter for the scale factor. And then in this situation we can see that this is not true. So 2.82, and then we have 4.47. So there's no, we can divide it by each other to see if this works. But here we have 4 and 4. So you can see right away that you have a 1 to 1 ratio on the long side, and then you have a different ratio on the angled side, and then you have a 2 to 4 ratio for this side. So you can see that this doesn't kind of satisfy on the similarity of the shapes. You can say like a scaled factor for maybe one side, but really you'd say for the shape over here, the scaled factor is 1 to 2 in this situation. Similarly, in kind of a simpler shape for a square. So we'll mark this as correct. Correct answer and explanation. Great work. And let's move on to question number 10.